Hello, and thank you for joining us for the second annual CrossLabs virtual workshop. This workshop is organized by CrossLabs, which is an interdisciplinary research institute located in Kyoto, Japan. We are supported by CrossCompass, which is a leading AI company also in Japan. This week, we'll be featuring speakers from all around the world to talk about artificial intelligence, artificial life, and the ways that artificial intelligence can extend our concepts of mind and intelligence. If you're joining us from YouTube, be sure to subscribe to our channel if you'd like to get notifications about this and other events, including our monthly Crossroads series. And it is now my pleasure to introduce our guest for today. We have Keisuke Suzuki, who will be talking about computational neurophenomenology. And Keisuke is with the Center for Human Nature, Artificial Intelligence, and Neuroscience at Hokkaido University. This talk will be about 30 minutes, and then afterwards we'll take questions via Slido for about 20 minutes. So whether you're joining us from Zoom or from YouTube, you'll be able to participate in that. So Keisuke, whenever you're ready.
Okay, thank you. Can you see my slide? Okay.
Yep.
Thank you for the kind introduction. I am Keisuke Suzuki from Hokkaido University. I am a lecturer at the Center for Human Nature, Artificial Intelligence, and Neuroscience, called CHAIN. So today I'm talking about a little bit about computational neurophenomenology. I think it's a kind of new term, but of course it's not a quite new idea. Try to understand subjective conscious experience by computational modeling. But I've been working on virtual reality and also artificial life, artificial intelligence. So today I just try to bring a new perspective using this new technology to approach the mind. So let's get started. I just start with a summary of my talk. It's just quite simple, actually. With the computational model, we can now create the first-person experience using deep neural network because it's scaled up compared to the classic computational model. And we can actually experience the output of the model using XR, virtual reality, extended reality technologies. And here we can actually go into the computational neurophenomenology, which is using computational model rather than simulating the objective performance of perception or cognition. We can directly simulate conscious phenomenology. That's the idea. And I think, again, this is not new idea. I think there's a lot of work and mathematical work to try to describe the certain phenomenology, but I think that combined with the deep learning, we can maybe in a bit different stage now. So just a kind of another summary, AI or artificial life, it's still third-person simulation of intelligence or some kind of performance we can judge or measure. For computational neurophenomenology here, we try to capture first-person experience directly by emulating it. Okay. So, I mean, this maybe not need to be mentioned, but there are two totally different approach to understand the consciousness or mind. Of course, one is experiencer approach, and another was empirical approach. I just open everything. And of course, the experiencer approach is more subjective, qualitative, and phenomenological, sometimes we say. And empirical approaches are objective, quantitative, and I think in a broader sense, it's called scientific approach. And it's sometimes confusing for me because experiential and empirical are translated into the same word in Japanese. So sometimes it's, I think even our original English meaning is both are kind of implying based on experience, but there's two different meanings here. Now, for example, if we study a certain type of conscious state, for example, someone under the psychedelic drug, some people actually try to visualize it. It's sometimes called visionary art. People touching this kind of a different state of consciousness try to visualize this specific experience. But on the other hand, of course, scientific, especially neuroscientific research on psychedelic, still talking about how brain responds. So, on the other word, try to find the neural correlate of the LSD effect for them. So, and yeah, there's a gap still between them, and it's called the explanatory gap, or sometimes it's called the hard problem. But anyway, we all want to kind of bridge a gap between this. And the one of the approach, and I mean, I'm not saying this is an experiential, but one subjective approach to the consciousness called the phenomenology. And the phenomenology is an attempt to describe conscious experience without making any assumption about its nature. And I'm not a philosopher, but yeah, it's a long history of this type of practice of studying the experience. And in the other words, it's a study of lived experience in the sense that it describes conscious experience as it occurs to an experiential in the stream or flow of their existence. So I think it's already have some dynamical view to the consciousness rather than statical view. And I think it's a quite descriptive study, but recently the phenomenology has been attempted to bring together the empirical science, like psychology, neuroscience, and stuff. So I think it's called naturalizing the phenomenology, and there's the various kind of way to attempt to bridge a gap between these two. And I think neurophenomenology originated by Barrera is one approach. It's a kind of first-person approach. We kind of being yourself in a certain type of conscious state. People have often used mindfulness meditation and analyze their conscious phenomenology. Other ways, for example, using second person approach, using like interview technique. So this is called phenomenological interview. So in this approach, like a scientist actually train the interviewer, and those interviewer actually approach to the target phenomenology by interview in a specific way. And another way is a more formal approach, like using dynamical system or information theoretic approach to phenomenology. So I think integrated information theory, one of the famous consciousness theory, is maybe categorized here because they starting from some it's called assumption based on our phenomenology in consciousness, and they try to make a kind of formal theory based based on that. So I think formal approach is not empirical, but anyway, there's a lot of approach try to bridge gap between phenomenology and other field of science. I don't know, this is maybe a bit redundant, but I'm originally from physics. So in physics, we also have the word phenomenological, and as a in contrast to a theoretical model. So for example, when we try to describe for example, like this kind of what's called fluid dynamics, we have, of course, each molecule actually follow the Newtonian laws of motion. So in following this point of view, we need to, sometimes people use like a molecular dynamical simulation of the water particle, water molecule. So each molecule is moving according to the simple formula, and basically just calculate everything. But also we have Navier-Stokes equation to describe the just fluid dynamics in more like a general macro level dynamics. And these two are not the same, but it somehow capture phenomenological model is not based on some actual theory, but try to explain like phenomena very well using like a macro variable or different type of theory, I would say. So I don't think this phenomenological in physics is the exact same meaning in phenomenology in philosophy, but I feel this is what I really want to do. Like phenomenological model of consciousness is something we need. We don't need to go into directly the neuroscientific, really molecular level of theory, but we can maybe develop some kind of phenomenological model of phenomenology, conscious phenomenology. And I'm personally really interested when we talk about consciousness. I'm always interested in outer state of consciousness because this, to me, like this is kind of evidence that consciousness is not just one thing, universal stuff. You know, I'm kind of happy to know that the different mode of consciousness exists. So I think that's a kind of starting point to study consciousness too. So altered state of consciousness are very, it's a different state of consciousness rather than like a normal awakening state of consciousness. So there's many different types: dream, trance state, hypnotic state, psychedelic experience, out-of-body experience. These are all categorized as altered state of consciousness. And there's many different ways to induce this state, like meditation. Sometimes it's caused by near-death experiences, hypnosis and isolation tank, and of course, psychedelic drug, substance, psychoactive drug, of course, in your mind. And in a visual domain, like perceptual experience are changed accordingly. So, and this is actually not just a drug, but also neurological disease. Like people in Parkinson's disease sometimes see this kind of very complex hallucination, or using like a psychedelic drug induce this kind of a geometric hallucination, or this kind of visual effect on your vision. And these are another example out of the experience that is sometimes it's called the astral projection in more mystical viewpoint, but this is just experience one person perspective separate from body and normally looking down from above. And this occurred in near-death experience, or like hallucination when you go into sleep, or under certain type of drug like ketamine, or even induced by electronic brain stimulation or virtual reality manipulation. So this phenomena, the out-of-body experience, actually exists, but it is actually induced by a brain, not like spiritual occultic stuff. So these are kind of phenomenology I want to understand with computational model assembly. And now I'm going to more like artificial intelligence or deep neural network stuff. So there is two different class of deep neural network nowadays. I mean, not nowadays, but we have two major categories. One is perceptual network, I call. I think the typical example is the deep convolutional neural network. This is really simple but highly layered feed for neural network. And this basically create a mapping from image to category level when we talk about the image. And another type of class of a neural network is the generator or generative network. This is mainly used for image synthesis or data augmentation. You know, it's create new data from the training data set. So like variation autoencoder or the generative adversarial network, this type of network. And I think the GAN, generative adversarial network, is one of the most successful neural network model in the last 10 years. Maybe not just this couple of years, but maybe from 2010. This is one of the great generator model. And I think GAN originally invented in 2014, but every year it's improved the quality and the resolution of the image. And I think in this 2019 big GAN, to me, with at a glance, I can't really see this is generated synthesized image or not, or real image anymore. So I'm not saying this is actual conscious phenomenology, but this is quite similar to what we actually see in daily life. So, I mean, this is kind of one example for deep neural network and scale up to the level we actually experience it in a first person perspective. And I just told the two people the two different type of network, and here, I'll just introduce my previous work for using deep neural network to simulate to a certain type of conscious phenomenology. We use a deep convolutional neural network, which is, as I said, it's a perceptual neural network. And it's trained for 1,000 different categories, image classification tasks. And interesting thing is the neural network automatically learn the future to process in each different layer. And it's perceptual networks. It's not designed to generate image, but there's many approach. There is proposed many different visualization methods to understand what these future each neural process. So one of that is called deep dream algorithm, developed by a Google research team in 2015. And they basically generate a new image which activate a certain target neuron most. So it's kind of inverting the neural network upside down to ask it to visualize what your favorite kind of image for that neuron. So in a normal neural network, we kind of processor, and when we train the network, we actually using back propagation to change our weight between the neuron in this way, like kind of top-down way. But once it's trained, it processes the image from the pixel level image to like labels in the top layer. But deep dream algorithm is again using this back propagation to change the input image directly, but fixing the each way. So it's kind of like a pseudo top-down process. So if you apply this algorithm to the any kind of arbitrary input image, it's just making the input image turn into the like image which activate the top layer of the network. So here you can see like a Van Gogh profile picture is turned into a lot of dog-like features or maybe snakes on the background. But these are kind of automatically chosen from the top layer of the future space. So it's interesting. And for that time, we're working on like virtual reality or kind of immersed the technology. So we had the video. This is a panoramic 360-degree video footage we recorded in a Sussex campus. And this is, I think, it's 3 minutes, and yeah, it's a 4K video recording. And what we did, just simply applied this deep dream algorithm into this 360 video. So by doing that, we can actually simulate. It's kind of like hallucinatory phenomenology, as you can see. Basically, you can find a lot of dog face again everywhere. And yeah, of course, this can be seen in the virtual reality goggle, so you're immersed into the hallucination. And this is kind of demo, but we also did some study using this. So we use like a psychological scale for altered state consciousness questionnaire. This questionnaire was actually used for compare people taking psilocybin, magic mushroom ingredient, and we compare like after watching this video, that's a blue line, compared to the original unchanged video. So we actually found like a lot of like, a visual aspect of the experience is highly different between control and hallucination, simulated hallucination video. And then we also did the between study comparison. So the orange is the other study who use psilocybin when they are, I think, line of fMRI. And after that, they rated the same question. And interestingly, we found a kind of similar pattern between hallucination machine and the people experience after the under the psilocybin administration. So this is kind of cool. this is kind of a additional stuff, but we also know the deep neural network, especially that the one I use, computational neural network, is actually quite similar to the actual biological brain. I mean, visual system in the brain. So when they compare what's called dissimilar matrix between the each layer of the deep neural network, and either V1, it's a lower layer of the visual system, or temporal lobe, higher layer of the actual brain area of the processing the object or stuff like that. In a higher layer of the brain is highly correlated with the higher layer of the artificial neural network, and other way around is also true for the early visual cortex. So in a sense, deep neural network is of course artificial, but functionally, I don't know if I can say functionally, but there's some similarity between biological brain and artificial neural network. Okay, and I just do some speculation why this deep dream algorithm makes some phenomenology similar to the psychedelic experience. There's actually the marked similarity between psychedelics induced experience and deep dream. And one thing I was thinking is, yeah, there's some study, of course, this future visualization study. Deep dream algorithm actually isolate the effective cause of the visual categorization. So in a sense, this, the creating this image doesn't need to resemble the actual sensory input. This is just exaggerating the future, which only important for the visual classification. So this is kind of opposite to this typical adversarial example study. Like adversarial example is like this picture is categorized as big, but with a really small noise. Now, this picture still looks like a pig for the human eye, human visual system, but this is now categorized as an error for artificial neural network. But these deep dream images kind of opposite. These doesn't look like actual things for human eye, but these pictures actually maximize the neuron in the artificial neural network. So in a sense, this is extraction of the most important feature of what neural network try to see. So I like this idea, and I think this is kind of related with the filtration theory of psychedelic effect. So filtration theory is, I think there is a long history, but this Aldous Huxley is famous for the book Doors to Perception, and he said psychedelic actually is working as a kind of inhibiting the inhibition system in the brain. What does it mean is basically he said like a brain, especially right cerebellum, having a kind of rich ocean of the old possible experience, but in a normal awakening state of consciousness, we kind of have a bulb reducing all this possibility, and just a really, I'll say, trivial, like very simple experience we only have, but somehow psychedelic open this bulb. So this kind of how to say filter is just gone. So we actually experience all these possible something. But of course, in this kind of 60s, they didn't know what it is. It is this kind of rich ocean of experience. I think this maybe that's just a kind of future which is used for the like a visual categorization, classification, and that doesn't need to replicate our actual physical sensory input. So I think this is actually two different stuff. Like our visual system try to create the conscious experience which resemble to physical visual input, but same time maybe brain also having a lot of information like extracting the future only used for the visual categorization. That's a kind of a inspiration I got. Okay, I only have 5 minutes, so I just try to talk another possibility of using a deep neural network to simulate the phenomenology. And again, this is maybe a bit speculation, and it's the model is not mine. It's my colleague Hiro Iizuka's model. This time, my target is out-of-body experience. And we know like there's a lot of computational model of self-further discrimination, but this self-further discriminating model or function cannot explain the actual phenomenology, why we actually see yourself from outside or why we have strange bodily experience. So it's a kind of, again, it's a bit two different things, like distinguish or recognizing your body or distinguish your body from others, not same as you experience your body or other body as yourself, or it's two different stuff, like generating that and perceiving the body is different. And this is the model recently published, led by Hiro Izuka, my colleague in this chain. And this model, they use this like quite simple neural network model, having the visual and also motor input to the I think the original, it's going to the like a convolutional neural network and then going to the I don't know, recurrent neural network, and then it predicts the visual perception in the next time step. That's all. And interestingly, there is another agent 2, in the environment. And the environment is also quite simple. There's 4 landmarks, different colors. And it, of course, can be trained to predict the next time step. And for agent 1, this is actually a trick. There's one module called shared module. And here, 2 different processes are superposed here and go into the predictor. And one needs actually process 1 is taking its own visual input and own motor output, these red lines. And another process 2, getting the own visual input. This is still visual input from agent 1, and predicted or kind of simulated others motor input from the agent 2. But important things here, note that agent 1 never takes the input from the agent 2 point of view. Always the visual input is from the agent 1. So agent 1 never experiences a scene from the agent 2, but just the simulated motor input for the agent 2 is into the shared module. And when they train the separate decoder for this visual encoder, they can, of course, reconstruct their visual input. What they actually encode in this module, they can actually decode from the future here. But interestingly, when they visualize using another decoder for the process 2, they can also decode the point of view from the agent 2, which never run from the agent 1. So that's their kind of main result in the paper. But I like their deconstruction. You can see there is some the black shadow over here. And I don't know, I think Hiro said this is maybe just a bug, but to me, this looks like a kind of agent 1. So again, the agent 1 is red color, which never seen by agent 1. They always see the agent 2, which is black color. And somehow when they decode the other's point of view, other's perspective, it looks like the black things appears and disappears. And I guess this is maybe a kind of reconstructing agent 1 based on agent 2 representation, because agent 1 only have seen the agent 2. But when they taking the different perspective, maybe you need to reconstruct the agent 1 again. But I think this is kind of like an out-of-body experience. I don't know. But like an out-of-body experience is, of course, it's phenomenological analysis for the this conscious state. And there's a different type of kind of orthoscopic hallucination. You see yourself, but your body is still there. But important thing is in our out-of-body experience is your point of view is floating above, and your point of view is here from the floating point, but your body is actually still in the physical location. This is the phenomenology of out-of-body experience. So to me, this is actually some explained by kind of mismatch between smart sensory aspect and also visual perspective aspect of own body. So maybe this model by Noguchi and Hiroizuka may explain this phenomenology of the out-of-body experience. But yeah, we need some more study. So I just summarize again, conclude. Simulating first-person experience with computational model could be possible now by using deep learning and deep neural network approach. And because we can actually create, generate a model output with a highly high dimension and a highly, how to say, not high dimension, but high resolution image and video. And in hallucination machine, we actually implement that with virtual reality, so people can actually experience that in immersive way, which is actually we couldn't do before. I mean, the model output is too simple to simulate the actual phenomenology. So this is kind of rephrasing the first stuff, but yeah, computational model, which actually I showed in a bit in the middle, but some computational model, deep neural network is some similarity to the actual brain. And we can use that kind of model to simulate conscious phenomenology rather than object performance of the perception or cognition. That's a kind of main message in this talk. And we can now directly comparing the real phenomenology and simulated phenomenology, which may be shedding light on a mechanism, which is maybe computational, but also neural and computational mechanism underlying the atypical or altered state of consciousness. Okay, I just put some kind of point we can discuss, just what I'm actually questioning when I'm doing this. So if we call this is computational neurophenomenology, is it actually complementary to the classic neurophenomenology or other approach of phenomenology? I mean, I'm not sure this is kind of new or complementary, or maybe it's not useful at all. So I wish someone from phenomenology background would be joining our discussion. And also, what is missing here? I feel like we just simulate the visual input, a typical visual input, but not actually simulating the actual conscious experience, of course. But what we actually miss here, maybe we need like multi-sensory, not just a visual exteroceptive input, but the multi-sensory and maybe interoceptive virtual reality we might need. Or maybe we need to directly stimulate the brain to simulate the experience. We don't know, but maybe in the future we could do that. And maybe another question, because I think still it's stay in the level of perception. So I just wonder how we can actually extend this approach to from perceptual to cognitive or affective, or maybe some more like highly abstract level of experience. Like how we can actually experience the simulated cognition, which is kind of related with the second question. But yeah, that's it. Thank you.
Great. Thank you so much for your talk. As noted, we've posted the link to Slido in the YouTube chat and in Zoom. So if you have any questions, go ahead and post them there. And before we get started with those questions, I have one question of my own, which is, yesterday we talked a lot about sort of embodiment and activism and things like that. So I was just wondering what your opinion is on, like, is there any way to extend this stuff to more embodied systems, maybe with robots or something like that? Or is that ridiculous? Is consciousness just sort of something that's just in the brain? Like, what are your thoughts on sort of the role of embodiment, I guess?
Yeah, I think that's of course the another really big challenge, and I'm really interested in also like robotic arm, or like what's called like a prostitute arm thingy, like how we can actually simulate like sense of agency, or like through the artificial bodily movement, for example. That's I think the one approach we can actually connect like embodied approach with this kind of synthesized phenomenology stuff. But again, I don't know. I just put the multi-sensory virtual reality, which kind of includes a kind of robotic system as well. And yeah, I personally also really interested in like extending the this kind of approach to, for example, like perceptual crossing paradigm, which from Froese, or this kind of embodied social interaction can be maybe synthesized by, one side can be replaced by AI, that kind of stuff. But I don't know this answering your question, but yeah, I think it's a really interesting direction.
Cool, thanks. So we'll take one question from Slido first, and then we've got Manuel here. But so we have a question from Kai. I don't know if you would like to answer that question since you're here with us, or ask your question since you're here with us, rather.
Hey, okay, yeah, sure, I can ask. So I don't know the details of this filtration theory, but rather than the brain having to sort of filter the outputs of the neural activity normally, in a similar way to deep dream, could it be seen that psychedelics are actually just pushing the neurons beyond like their normal operating regime? So it's just in an area where they're not expected to be operating, and that creates the effects.
Sorry, I just missed. What is your actual question?
Rather than the brain normally filtering neural activity, could psychedelics just be pushing neurons beyond the normal activity?
Oh, I see. Yeah, but yeah, I think that's like a normal way to explain the psychedelic effect. But I just want, in that way, I wonder why that specific phenomenology, like geometric. I mean, that also can be explained by like maybe like a lower layer of the visual cortex actually processing like lines and edges. So yeah, as you said, maybe just over-activating like a lower layer of the neural network, maybe causing that phenomenology. I agree with that. But also there are, yeah, so again, like then why there's kind of hierarchical structure, like why certain type of psychedelic only affect to the lower layer of visual cortex. So I think we still need to explain not just activating the neuron, but why this specific like phenomenology is caused. So, but yeah, I don't know. Maybe it's all kind of all speculation for that part. I like the filtration theory, and I just want to bridge gap between like old theory to the modern interpretation. So, thank you.
Cool. Thanks for the answer.
Great. So next we'll take a question from Manuel in the Zoom room.
Thank you, Lisa. Hi, Keisuke. So I guess I like your analogy, say, with phenomenological models in physics. There are differences, but I like the analogy there. I think, people that do phenomenological models in physics, to validate them, they go two routes. They either just pile a lot of evidence and they try that, for 100 years and it always worked and it's a good model. Great. Or they just try to control a system with such a model to see, okay, how effective it is. Like, how many different configurations can I push this system that I'm modeling, with this very simplified, perhaps set of equations? How can I, make it do what I want it to do? So thermodynamics, like controlling steam engines, fluid dynamics, like controlling, like, how fluids are actually flowing, like in different situations. What do you think will be the equivalent for, say, phenomenology or, your computational phenomenology? Is it like virtual reality? Is it drugs? Is it something else?
You mean like how to actually test or how to interact with real stuff? That
control. Yeah.
Control.
Control, like, I don't know, if it's like a good model of or conscious experience, I should be able to control that conscious experience.
Yeah. I mean, I think in like ultimate way, we need to stimulate the brain, like in a certain way. So if we kind of have a hypothesis how, for example, certain psychedelic drug affect the brain, maybe we can test that by directly stimulating certain part of the brain in the same way. It's not the area, but certain dynamics or simulating like a macro dynamics, which is kind of work in similar way to the actual psychedelic drug to test what we actually experience with that. So I don't know. I feel like virtual reality is still, in a sense, it's just a simulation, but not the actual generation of the experience. I agree on that. So, but I mean, but on the other hand, psychedelic drug itself, maybe it's too, it's just there. We can't really test different type of drug. I mean, of course, you can pharmacologically change the type of molecule, but we can't really simulate or like test computational mechanism underlying the psychedelic using just a psychedelic. So I feel like I mean ultimately we need inserting direct node to the brain to simulate psychedelic state with certain computational model. That's a kind of interesting way. I think the control can be, I mean, like I feel your question is control to me is like a causal effect. So the model here doesn't just, it's not just a kind of descriptive model, but the model actually doing something in a real experience. And to test that, we actually poking the brain itself, I think, especially on your own brain.
Yeah. I think, I was wondering if there's like some macro intervention we could do. So if you look at, I don't know, some of Levin's work, like with some of these worms, like, instead of actually poking like the inside, you put them in some, electrical field.
I see.
And
I see. Maybe, yeah. I mean, maybe it's different things, but sometimes I feel like a hypnosis is really macro level. It's just a barbell influence, and it's kind of sometimes sufficient to change people's experience, like a phenomenological control by sussex people. So maybe somewhere in between, like a mesoscopic stuff. Yeah, it's interesting idea.
Well, yeah, definitely lots of fun stuff to keep discussing here. Again, feel free to stick around after for more discussion. We do a lot of questions on Slido, which is exciting. So we'll take one from Slido and then move back to the Zoom room. So we had a question from Dobry, who is here with us. Dobry, do you want to ask your question?
Oh, hi. Thank you for your talk. My question originally was, why do people always keep Heidegger? Like they go from Husserl to maybe Merleau-Ponty, but they forget. And but more, it's like that's not so important. I guess the more important part of the question is, which branch of phenomenology informs your work, right? So phenomenology itself has a history, has different ideas. Some of them contradict each other. There have been fights for centuries. So which of these is useful gives you useful insights to understand the deep learning-based models and simulations?
Yeah, that's a difficult question. I mean, I'm actually surrounded by a lot of phenomenologists here in Chain. So I need to ask them as well. But I'm not a philosopher, so by the way, I cannot answer the question why Heidegger is skipped. But I think, yeah, that part also, there's many different point of view, opinion for that. So I think I'm more familiar with the Merleau-Ponty's idea because I'm from like embodied cognition and inactivism idea. But the talk I gave today is, I think it's a bit more general. I use a phenomenology really naive way. It's just something like you experience in even daily life. Anything you see with the detail, not the like a direct experience, not the like a concept or something like that. So in that sense, for this specific work, just copying or simulating certain phenomenology, I don't know what kind of philosophy's school is useful in this way, but sorry.
I'm curious if you could if with your colleagues you discussed going the other way, instead of using phenomenology to inspire the modeling, to use the modeling to inform the phenomenology.
Yeah,
Like
I think
now we can
that's
resolve those debates.
Yeah, actually, the work I gave in the second part, out of body stuff, is a collaboration with a phenomenologist and the artificial life researcher. So I think that that's a great idea to making a loop between phenomenology people and artificial life people.
Cool. From our next question, we've got Jan in the room.
Yeah, thank you. So I think my question goes back to the filtering idea. I think that, well, this is based on, I mean, this is not my area of expertise, but, and also it's very late here. But in any case, I was wondering whether this is related to the idea that while we are awake, there's a constant, well, at least more or less constant filter of, well, things being realistic and making sense in operation, and that is, well, somewhat less stringently applied, maybe in dreams and also in, well, whatever that is, like altered states. Well, how this is related to the to phenomenology, and well, as an additional observation, I mean, well, that's maybe just a curious thing. I think that, well, having seen a bunch of these GAN-generated images, well, they are very convincing at first glance. But, well, I mean, having just seen a few of them, or maybe more than a few, but I mean, a number of them, again, not, well, this not being any of my area of expertise, I've got to say, I mean, I kind of know what to look for. And most of the time, if you look even a bit more closely, they are not very realistic. As one example, I noticed that picture of the like an inflorescence with the butterfly sitting on that. Well, I mean, it looks plausible enough at first glance, but I couldn't see any body of the butterfly. I mean, there were just the wings. Yeah. So, and I mean, that's the typical kind of stuff that these GANs generate. I mean, they are not realistic. And if you apply consistent model of reality, I think to this day, I haven't seen anything that was particularly convincing.
Okay, so did you have a final question that you wanted to add?
Yeah, the question is really, I mean, what's the role of this filter of reality and the sort of the overall model of reality as opposed to the visual level, which is much more shallow?
Yeah, it's a really interesting, I mean, difficult question as well. I feel like, yeah, maybe we have I think it's recently it's getting more discussing about this reality monitoring idea. I think reality monitoring used originally from like a memory study, but now maybe our brain actually has a function to distinguish between real and imaginary things. And yeah, I don't know, like it's actually what is the actual function, why we need to feel real from fake. But another point I feel like that you said, like for GAN, I have the similar feeling, you know, like at the first glance, it looks like real, but when you go detail, it's actually not of a contradiction. And I feel this kind of similar feeling when I have lucid dreaming. You know, it looks like real, but when I try to see my hand closer, it's just blurred, or, you know, all the detail is gone. I remember that feeling, you know, like I never seen, for example, a camera from the really close. So it looks like camera, but I don't have any detail in the dream. So maybe GAN is just like a dream, actually, you know, it's just like reconstructing the reality and it looks real. So because in a dream, we kind of reducing like a prefrontal cortex activity, which means like we are less having like a metacognitive function. So the reality experience of reality have also kind of different layer. You know, it's sometimes we believe this is real, and it's a bit different from perception. It looks real. So it's a kind of big field, like how our mind feels something real. But yeah, it's a difficult one.
Yeah, I think, I mean, we're generally, when people have a deeper understanding of reality that goes way, way, way beyond the visual level, and yeah, I mean, I think in some way, where GANs are not restricted to the visual level as well, although they are very frequently applied at that level and not much beyond. I'm not too certain whether it's a matter of extending towards this more realistic and less dependent on the visual level, or whether there's something more fundamental to this.
All right, so we have time for just a few more questions. Looks like Olaf, two of your questions are up on Slido. Maybe you can pick your favorite and ask it.
Sure. Which one is my favorite? Let's pick the fun one. So can we use computational neurophenomenology to go further than emulating our conscious experiences? So for example, can we use that to augment our human abilities? And perhaps do you have examples of that in the recent years with breakthroughs, perhaps in due to deep learning and so on?
Yeah, that's interesting. Because so far, like our kind of, for example, hallucination machine is kind of still limited to the visual domain. So I just talked about the possibility of the visual domain, but one thing I'm really interested in is can we actually create like a hyper realistic experience? You know, like there's a neurological mental condition called the depersonalization. People start losing the sense of reality. You know, everything surrounding you looks unreal. But I just wonder, by using this kind of visual, I'll say, manipulating the visual aspect of the scene in real time, we can maybe create like a super realistic, hyper realistic visual experience. You know, it's converting the normal visual perspective to the, I don't know, maybe it's going to be closer to the deep dream, but I just wonder, you know, if we can actually, so in a kind of perceptual level, we could maybe enhance our kind of sense of reality or other kind of aspect of it. For example, we could maybe make like enhancing the emotional aspect of the perceptual experience, and everything looks more familiar. Or I don't know. This is maybe more tricky because it's affecting the. So it's need to be trained with your affective aspect of your mind. But something like that, you know. I think what the movie? It's a kind of cyborg, but extending their perceptual level, like a Ghost in the Shell. You know, people actually see there's something we cannot see with the naked eye, something like that. So I think perceptual cyborg would be a nice idea to.
So you're saying that the breakthroughs are rather in creating feedback loops through our perception mechanisms, right? Rather than adjusting our motor responses directly, right? So it's always through our decision making at large.
Like changing the perceptual flow external to make some change in your perception system.
Thanks.
So I think we have time for one more question. We'll take this from Azal in the Zoom room.
Thank you. I was wondering, actually, dream is very, I think, very unique for everyone. And I think this kind of out-of-body experience, I mean, just before asking the question, I'd like to share that when I was in high school, I just take some meditation sometimes and then sleep on bed and try to imagine myself from outer camera or this perspective. And I'm walking through a forest, and there is any degree of, I mean, I can see myself from any view. I try to imagine just for fun. But later I discovered that when I sleep, I saw more dream about outside of myself. I mean, It's not just by a byproduct of my dream. I found that maybe it is possible to train also to experience this kind of thing. Now, my main question is, I found that dream is very complex. And just today morning, I couldn't count the exact number in my dream. And I could feel that I cannot count, but I'm in dreaming. So my question is, current deep neural network or this kind of thing, they are just to optimize for 1 or 2 scalar or 3 scalar value, just very simple optimization. My question is, this kind of model, do you think this kind of current deep learning model is mature enough to represent this kind of dream or out of body experience? I mean, are they matured enough to explain this phenomena?
What do you mean matured? I mean, like it's a
I mean, deep neural network, still GAN or convolutional neural network, they are trying just optimize for some scalar value, the loss objective. So just very simple optimization technique. But our dream consists of logical unit, very strained thing. So if we get some similar result from deep neural network, can we say that this is the explanation of this kind of phenomena?
Yeah, I don't know. I mean, I feel like the richness of the output is not it's not directly related with the loss function. Like GAN is using like one loss function, like adversarial loss, but it still it's still like optimization. It's just try to mimic the distribution of the data set. But I think because of the training data set is huge and the really, I would say, diverse, it also creates a diverse diverse output. So I feel, this is kind of my intuition, but I feel after this deep learning, I feel the data set is more important. Our human see that kind of rich dream because we see the world and the world is really rich, and we've seen this since we born. So I feel it's not about deep neural network itself, what kind of data set we train it. That's my kind of intuition. So I think neural network itself can be small. Maybe if it's too small, of course it doesn't have the capacity. But if it's like complex enough to process or like learn certain stuff from the data set, I think it's enough to study phenomenology. Of course, dream is difficult. Of course, there's as you said, there's so many different strange stuffs happening in a dream, and all the aspect of the dream is not just perception. As you said, it's more like you can take it as a perspective, or you have like a really strange. Let's say, when I have the lucid dreaming, like I have a strange feeling of I don't remember anyway. So yeah, it's of course the beyond the perceptual experience. There's a lot of stuff in dream, and I don't think current deep learning is enough to simulate all of them. But I feel richness of the model is not inside the model, but it's more like data set. So it could be done with the current version. That's my intuition.
Great, thanks so much once again, Keisuke, and thank you everybody for joining us. Again, whether you're here on Zoom or if you're on YouTube, you can join us again tomorrow for our final talk of the week, which will be Artemi Kolchinsky talking. So again, stick around if you're here with us on Zoom. Otherwise, we will see you tomorrow.